So in the last class we did for the linear regression, we built a model using the linear regression. That is the one that had c y is equal to a plus bx. What page is that? That we built a model using a simple linear regression equation, which is this, where you can predict the dependent variable if you have the independent variable. So this is, if you look at this equation of a straight line, which is mx plus c. It means that it increases like this. But in some situations, it doesn't work like this. So it doesn't work like this. Maybe the variables, they don't increase uniformly. Sometimes it doesn't work like this. Then for you to build a model that will be able to give, because remember that last class that after building that model, we just chose a random value of x and inserted it, and we got a value that's very close to y. That if the system we are trying to model doesn't follow a simple linear pattern, using this method to build the model will not give you that y if you put a certain value of what x. So that brings us to today's topic, which is polynomial regression. That is, if it doesn't go like this, maybe it goes like this, or like this, or like this. Then using this method now, we can be able to build a model that can fit. Do you understand? So in this case now, the equation we're going to the equation is going to look like this. That the dependent variable y will be equal to b naught plus b1x plus b2x0, where y is the dependent variable, x is the independent variable, then b naught, b1 and b2 are the estimators. It's saying that if you know b naught, b1 and b2 for a particular operation, you'll be able to estimate any dependent variable given the independent variable. So to find b naught, b1 and b2, we need, because there are three unknowns, so we need three equations. So the first equation is quite much, but it follows a certain pattern. Y, direct y, s I y, y I, s I y I, s squared y I. This is what I did now. You start with y I. The y was constant. Then the s will increase from 0 to 1, 2, till infinity. But we are looking for what? Three unknowns. We just need three equations. So we stop at. Do you understand? Yes. We have three unknowns. We need three equations. So this is y I. This I means that this y is maybe from 1 to whatever. So we are summing the y from n. Assuming this y now from n equal to 1 to n equal to what? I. So the I now starts from 1 and end at what? N. Here now, the I starts from 1, end at n, starts from 1, end at n. So let's develop the equation. So this one now doesn't have x here, doesn't have s. So the first term will not have s. It will be naught times n. B naught times n. Then you now say plus b1. Then you now sum your s from 1 to infinity to n. Then next one is what? B2. Now sum your do you see the pattern? How is it moving? The first one doesn't have s, and the first coefficient is what? B naught. The second one, you now introduce your x, that's power 1. The third one, you introduce the second constant, which is B naught. You now increase the s from power 1 to power 2. So you do similar thing till infinity. See that there's no s here. It means that it starts from a event that doesn't have s. So B naught will not have s. Then the next variable now, the next constant will be b1. Then you now introduce your s. The next variable will be b2. The s will now increase from power 1 to power 2. Then as we are going to have a b3 now, it will now be b3 sum of x I cube. Let's let this increase. B I x I r. Do you understand how it progresses? See this equation now. So start from b naught, b1, b2. See that the s. See that in the first one, for the first variable no s, then the s now increases from 1 to 2. So in our first case here, there's no s, that's for y. There's no s in the first variable. Then you now introduce s in the second one.
That n is in the range, the maximum range.
The n is the number of the population. This is the population. Then this second one now, then this you now introduce the s will now start increasing. So in this second one now, let's see how we start. Second one now, we multiply, let's say I multiply this thing by s now. Abi? Then this first one will now have s. This is y, abi? We want to find s I y I. Means we multiply this equation by what? S I. Means that this first b naught now will now have x. Will now be what? B naught s I. See this s has I. It means that it will be summation from I equal to 1 to n plus b1. This I now will now increase. We now have summation of si squared plus b2 summation of si3 then this one now tell us that the first variable we have s squared and this s squared has I, it means a summation. They will now say B naught summation of Si squared. Go to the first one now. The second one now will be B1 summation of Si cube equal to 1n plus B2 4. So we solve example now. We just need to generate these three equations, then solve the equations to get values of B naught, B1, and B2. And after inserting this here now, we've now created a model that we can use to predict the dependent variable between the independent variable. So the example here says that we should fit page 12 should fit a polynomial to the following data. Should fit a polynomial to the following data. It was given. Once you know this first one, this is the rest. So we have an example that says should fit a polynomial to the following data. That's page 12. So this one means that we should sum all values of y. We put it here. Then we know n is the total number of samples or population. Yes. B naught is unknown. B1 is unknown. S n means that we should sum all the values of S. Don't you understand? This one now, B2 is unknown. This one says you should square each value of S, then sum everything. We have different values of S. Now we should square. We should sum it. Once we have 2, 1, 2, 3 for a value of S. Do 1 squared plus 2 squared plus 3 squared plus 4 squared. You now add everything together. Then you've gotten your first equation. Second equation says that you should multiply corresponding values of S and Y. Then you add it. Let's say this is our S. Then our Y, this one is have 2, 4, 6, 8. This S, Y means you should do 1 times 2 plus 2 times 4 plus 3 times 6 plus 4 times 8. And once you are done, you should add it together. This one say, okay, B naught is what? Unknown. Si, we got it already. That's the summation of all your values of x. Then Si squared, we got it already. It means that we should square each values of s, then sum everything together. B2 is unknown. S cube means we should take this cube of each values of s, then sum everything. Then for the third one, say that we should find s squared yi. Square your s, multiply it by your y, keep it, plus square your another s, multiply it by the value of y. Once you are done, you sum everything together. Then here now, still the same thing. You find solution of the squares of all your s, put it here. Cube of all your s, sum everything, put it here. Then find the cube, the fourth. What's 4 again? What's base power 4? Fourth. What's the power? It's power 4. Just take all your values of s to the power of 4, then sum everything. Exam. You'll be giving your value of s and y. Let's say this is 1, 2, 3, 4, 5. This is 2, 4, 3. Okay, we now do s. Since we need s squared, We need S squared. We also need S cubed. Have you? We also need S4. Have you? You just do 1 squared, 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25. The S cube is take this to the power of 3. Power of 3, 8. To the power of 3, 27. To the power of 3, 64. To the power of 3, 75. 75? 5 times 5. No, wow. 25 times 5 is 125. 125. Then similar thing here. Abi? Then you now to get this is let's call this is I. Remember here now we just need summation of what yi. We sum these ones and get our what answer. Keep it there. Abi? This one say you should multiply s and y. So now do s y. So now have s and y colon. So you do 1 times 2, 2, 2 times 4, 8, 3 times 3, 9, 4 times 4, 16, 4 times 5, 25. They want to sum this now. We've gotten this one. Abi? Then the next one is what? S squared yi. Mean that you multiply your s squared by y. The 2 times 1, 2, 4 times 4, 16, 3 times 9, 7. Once you sum it, you've gotten this answer. So we're going to skip to the answer. So we'll not show, let me show you how to solve the 3 equations. Because it's more than 2. 2 is simultaneous, it's more than 2. So there's a way of doing it. So we're clear here, Abi? So let's try and practice. If you don't practice, you will forget. So let's don't write this one, it's just illustration.
You can do it.
Let's do it. Let's do it. So this one now we sum all our values of y.
First y squared.
The first one is sum all values of y. We got 1290.9. Then our b naught is constant, which is an unknown. Then n is the total number of the population. That's the samples. So it's 10. Then our SI is we summed all the values of our x, we got 55. Then the S squared is take the square of your individual s and sum it, we got 385. The next one is summation of SI, YI, meaning that we should multiply each corresponding values of s and y and sum it, we got 9549.9. Then we now multiply the b naught by the summation of x. And we already got the summation of s to be 55. So 55 times b naught, we have 55 b naught. Then this one is what? b1 times summation of x squared. So we found our s squared to be 385 times b, I will have 385 b1, sorry. Then the next one is our b2 times sum of s cube. So we take the cube of the individual values of x and sum everything. We got 3025 b2. The next one is summation of s squared y. So you take the square of a particular x, multiply it by the corresponding y. We do that individually, then we sum
the summation.
We get 775.8. Then we already know our x squared to be 385.
So we just have to create the table.
Create the table to be very easy. So
that is how many tables now? 1, 2, 3, 4, 5, 6, 7.
Once you do the table here, you now go over it again to cross-check your answer. Then you are done. Then you now start implementing.
So we create table for summation of x raised to power 4.
Because you have your s, your y, you have s squared. No, you have your s, you have your y, you have sy, you have s squared, you have s squared y, you have s cubed, then you have s4. That's what they require. So we want to now solve these 3 equations to get our values of b0, b1, and b2. So this one will be practical. So the first thing to do is to make B naught the subject in the first equation. You make B naught the subject here. So you make B naught the subject from equation 1. So we need that we should bring everything to this place. So we have 10 B naught is equal to 1290.9 minus 55 B1 minus 385. Then our B naught is equal to divide 2 by 10. Divide 2 by 10, we get our B naught to be equal to 129.09 minus 5.5 B1 minus 38.5.
38.5.
Hello? So once you do this now, you now take this B naught and replace it in equation 2 and equation 3. Now reduce it to 2 variables. You now solve this and this equation. So putting the value of B naught, which is equation 4, into equation 2 and 3. So this one will now have 9547.9 is equal to 55 bracket 129.09 minus 5.5 B1 minus 38.5 B2 plus 385 B1 plus 3025 B2. You now open the bracket, you now have 9547.8. When you simplify now to put this bracket, do you understand? We just see that equation 2 now. Equation 2 has B naught, and we already found the value of B naught to be this. So putting the value of B naught, which is our now equation 4. Okay, which is equation 4 now, or that equation 4 now, into 2 and 3. So I think for the first one, now which is equation 2, we are putting our B naught to be equal, which is equal to this into here. Now we now get this. So if we open this one, now what we get? If we open this one, we get 7099.95 minus, is it 302? This is 5 times 5.5. 302. 302 point.
How can 151 times 129.29?
You see now, 5 times 129.09.
55 times, maybe this calculator, no? 129.29.
It's correct.
302.5 is correct.
7099.95. Then this one is now what? Minus 2117.5 B2 plus 385 B1 plus 3025 B2. Now collect like terms. This and this and what? This. So this is 95. So we now do minus 302.5 plus 385. Abi? We get minus what?
Minus
Minus 82.5 B1. Abi? Then we now do minus 2117.5 plus 3025. This are you know say we open brackets now. We can't get this one. Yes. I mean, so we still have 385B1 here. We still have 3025B2 here. So that we have B1 and B1. They be like terms. Come add them together. You understand? So we can't do minus 302.5 plus 385. Just like saying minus. You can the like that. Yes. That's how we got 80.5 B1. Then minus 2117.5 B2. We also have 3025 B2 here. Yes. Correct like times again. So what do we get? 9 what?
907.5.
B2. So we have another like terms here again. This one, they are both numbers. Yes. So we can bring this one here. Yes. So we now have 9579.9 minus 7099.95 is equal to 82.5 B1 plus 97.5. So this will give us
2447.
So can I clean this place now?
Yes.
I want to clean this thing and put the answer. So it was
2447.95.
2447.95. So let's go this equation A. So we now put B also into equation 3. Then we now put B naught here now. We now have 77758.9 is equal to for the second equation. We're now replacing B naught in the third equation, which is this. So we now have 385. Our B naught is 129.09 minus 5.5 B1. Minus 38.5 B2. This one now. Replacing B naught.
Replacing B naught.
This is equation 3. Yes. Replacing B naught in equation 3. Then we now have plus 3025 B1 plus 25333 B2. So we now put the bracket also here. So we now have 77758.9. Help us here. I think it should be the same thing as this. Help us here.
49699.65.
Then minus 385 times 5.5. 2117.5 B1. Then the next one 14822.5 B2 plus 3025 B1 plus 25333 B2. Now collect like terms. 77758.9 minus 49699.65. Then B1 and this one, they are like terms. So we do 2117 907.5 B1, yes. The next one is
One oh five one.
then now we have 77758.9 minus 49699.65. This is 28,059. So this is our equation B. So solving A and B simultaneously. So if you solve equations A and B simultaneously, B1 is equal to 6.07 and B2 is equal to 2.146. So you take these things now, look up, put your B1 here, put your B2 here, you found your what? Your B0. Then your equation is now what? You now put your B0 here, put your B1 here, put your B2 here.